between strength and stress. So strength is an inherent property of the material, and that can be calculated using universal testing machine. Universal testing machine that can be calculated. Each material will have its own strength. In actual real life, you might have seen a number of materials. So most of the cases we are using steel. Steel is a alloy of iron. If you mix some amount of carbon with the iron, it will become steel. Again, it is low carbon steel, medium carbon steel, high carbon steel based on the carbon content. So as you add carbon, the property of the material will change. So each material will have its own strength, own properties. Different properties are there. Ductility. So it will have its own property like hardness, tensile strength, shear strength, and malleability. So many properties are there. So for us, in this strength is very, very important. So strength is an inherent property of the material. It can be calculated using universal testing machine. Right? For each material will have its own strength. Right? What is stress? The strength value will be always constant for a particular material, but stress value will be different. It is depending upon the amount of load applied. If you apply less amount of load, less stress will be there. If you apply more load, more stress will be there. How to calculate the stress? If it is a axial load, the stress can be calculated by using the equation load by area. You might have studied this equation, load by area. Generally, if you want to tell, stress can be calculated based on the applied load and dimension, because sometimes all the time the structure will not be subject to axial load. Sometimes it is bending, sometimes it is torsion. So when different conditions, it is subjected to different condition, we have to use different equation. Generally we can say the stress is a function of applied load and dimension, right? Applied load and dimension, this is a stress. For example, if you want to design a component, if you want to design a component, you don't know the dimension. Actually, design means what is the design? Arriving the dimension. So dimension is not known, but all other conditions are known. For example, how much amount of load is going to be applied, that is known. And the strength, what material you are going to use. If you know the material, the strength is known. So strength is known, and loading conditions are known, but the dimension you don't know, we have to calculate. In such cases, what you have to do is, you have to compare the strength and stress. You have to compare the strength and stress. Strength already known. In stress, we know the load, but we don't know the dimension. So comparing these two, you will be able to find the dimension. That's what we do in design. Why you have to compare the stress and strength? As per theory, strength is a material property. Stress is induced in the material. When load is applied, the stress is induced. When as long as the stress is less than the strength, there will not be any failure. There will not be any failure. As stress reaches equal to strength, there will be a failure occur. Then failure will occur. As long as stress is less than strength, there will not be any failure. So you can find the dimension by comparing the strength with the stress. So any dimension in this subject, strength of material, our objective is to study how to calculate stress. How to calculate stress. Not only for it is for different conditions. Different conditions. If it is axial load, or bending load, or torsional load, or that is power transmitted. In all different cases, how to calculate stress. That is our objective in this subject. We have 5 units. Let us start with first. Mechanics is divided into two. One is mechanics of rigid body, another one is mechanics of deformable body. You can see mechanics of rigid body and mechanics of deformable body. If you assume the material is engineering mechanics, and if you assume it is a deformable body, then it is strength of material. So in strength of material, we consider the material is deformable. It is a deformable. In deformable material, there are two materials are there. One is solid, another one is fluid. Solid we know, Fluid also we know. If you study about fluid, that will be fluid mechanics. We are interested in solid mechanics, solid. And solid also, it may be elastic and plastic. You know what is elastic, what is plastic? When load is applied, there will be deformation. If load is removed, it will regain the original shape. That is elastic. Plastic means when load is removed, it will not regain the original shape. We are not interested in plastic. We are interested in elastic. Again, it is linear, non-linear. Linear means, you know, Hooke's law. According to Hooke's law, stress is directly proportional to strain. If it is directly proportional to strain, that is linear. If it is not directly proportional to, then it is non-linear. We are interested in only linear. And static or dynamic. We are interested in static. Dynamic means the body in motion. We are not going to study body in motion. That you will be studying in kinematics and dynamics, not this. So we are interested in statics. So our objectives: you study the solid, elastic, linear, it in stationary, static. For a member in stationary, but the member should be linear and should be elastic and solid. So for this material only, we are going to study the stress. We are not interested in other materials. In strength of material, our objective is to calculate, to determine the stress of a solid body, but it should be elastic, linear, and static, right? Now let us see some. If a material is subjected to another no deformation or negligible deformation, that is known as rigid body. Then deformable body, it is divided into two. One is elastic body, another one is plastic body. Elastic means when load is applied, it will deform. When remove the load, it will regain the original shape. In plastic, it will not regain the original shape. That is a difference between elastic and plastic body. Both are deformable, but there is small difference. But we are interested in elastic body only. Then what is strength? How the strength is developed in a material? It is because of the cohesive force between the molecules. Solid is made up of molecules. There is an attractive force between the molecules that keep the strength. Stability means the material is stable when load is applied. That is, it won't fail. Uh, Withstanding the load without failure or fracture is known as stability. Once it is failed, it is unstable. If it is not failing when load is applied, that is stable. Then there are three different types of loads we are going to see. See this one, the first one. Here, load is acting away from the body. That is tensile load. Here it is acting towards the body. This is compressive stress. Here it is acting tangentially. This is known as shear stress. So because of this load, the stress developed is shear stress. Here see, load is acting in this direction. The failure takes place perpendicular to the surface, perpendicular to the load. Load is acting along this direction, but failure is taking along this vertical direction. So both are perpendicular. So this is another tensile stress. Here also it is perpendicular only. Here also it is perpendicular only, but the nature of load is compressive. So this is compressive stress. See, in case of shear stress, load is acting along this direction and failure takes place in this plane. Failure takes place in this plane. Both are parallel. Both are parallel. So this is called shear stress. Here you can see in the rivet also. This is one plate. This is another plate. Both the plates are joined by a rivet. When load are acting, the failure takes place along the direction. Along the direction. Load is acting along this in the horizontal direction. Failure also taking along the horizontal direction. Both are in the same plane. Then it is that type of stress developed is shear stress. Type of stress developed is shear stress. But in tensile and compressive, both are perpendicular to each other. Direction of the load and failure plane are perpendicular. But here both are parallel. Generally, we call it as a this load. The when the loads are acting tangentially, the type of stress developed is shear stress. So these are the three type of stress. And mechanical properties: elasticity already we have discussed, plasticity we have discussed. In elasticity means when load is applied, the material will undergo deformation. When load is removed, it will regain the original shape. And plasticity, it will not regain the original shape. And ductility, it's a property of the material enabled to drawn into thin wires, thin metals. That is ductility. Ductility, malleability. There are both are almost same, but ductility means it can be drawn into wires, but malleability means drawn into sheets. That is a difference. Both are almost same, but the opposite to the ductility is brittleness. Ductility is the property of the material to enable to drawn into wires. That is ductility. Brittleness is just opposite to that. When load is applied, it will fail without giving any deformation. It will fail. So that is brittle material. So toughness means the the property which enables a material to resist fracture due to impact loads. The load can be generally three types of loads are there. One is gradually applied load. Another one is impact load or shock load. Suddenly applied load. We can call it as a suddenly applied. Load is applied suddenly. And the third one is, if, for example, suddenly applied load means you take a weight for a height, you drop it suddenly. You drop it suddenly. So it hits a surface with some impact. That is impact load. If the same load is just kept over the body, then that is gradual applied load. Dropping from some height is an impact load. So toughness means how a material is resisting an impact load. That's what toughness, right? And then hardness. Hardness means the resistance of the material to indentation, scratches, cutting. For that is hardness. That resistance of the material to form indentation or scratches. Hardness. Fatigue means similarly. We have seen one term that is what is called toughness. The toughness, like toughness, there is a term fatigue. Fatigue means the resistance of the material for cyclic load. Impact load means when the load is dropped from a height, that will create impact. What is cyclic load? Cyclic load means the quantity, the magnitude of the load will be changing continuously. You see, just like a sine curve, just like a sine curve. Initially, if the load will be zero, after that it will be maximum, then again it will come to zero, again it will be maximum in the opposite direction, negative direction, then it will be zero, then it will be maximum in the positive direction, then it will be zero. It will be like a curve. It will be continuously changing with respect to time. That is known as cyclic load. So how a material is resisting the cyclic load, that is known as fatigue, right? Then resilience means the amount of energy stored in a body per unit volume. Amount of energy stored in a body per unit volume is resilience. Proof resilience, another term is there. That is maximum amount of energy stored in a body is known as proof resilience. How energy is stored in the body? Because of the strain. When load is applied, there will be a change in dimension. Due to that, the energy is stored in the body. I will see detailing in the next slide. Then stress is equal to load by area. That this is a body. Tensile, it is subjected to a tensile load, opposite direction. Due to the load, there will be elongation. It's shown in yellow color, delta L. Initial length is L. After deformation, the length is delta L. Now the stress sigma is equal to P by A, load by area. That is a stress. What is strain? Strain is equal to change in length by original length. See, this is delta L. This is delta L, change in length. This is a length. So now stress is load by area. Strain is equal to change in length by original length. Stress is strain. Another term is um, another Young's modulus. Young's modulus. By stress by strain. That is the what? Young's modulus. Already we have the equation for what? Stress is equal to load by area. Load by area. What is strain? Strain is equal to change in length by L. Now you can write this equation P by A, right? If you receive L by delta L. So Young's modulus is equal to sigma b or Pa by L by delta L. This equation also can be written as delta L. This equation we will be using frequently. Delta L is equal to PL by AE, area into Young's modulus. So I have taken sigma here and Young's modulus here. So delta L is equal to PL by AE. This is one equation. To find change in length, you can use this equation. P is equal to load, L is equal to length of the member or structure, area is equal to cross section area, E is equal to Young's PL by AE. Right. Next term is work done. We are going to calculate work done. To calculate work done, already you might have studied. If you want to calculate work done to move a body from one position to another position, one position to another position, that is W into X. That is a work done. You might say there is a body, one body we have, some amount of force is acting on the body, that is P, load is equal to W. The body is moved over a distance of delta. Generally we take X, but here you let us take delta L. Now the body is here. Now work done is equal to what? It is moved over a distance delta L. So the work done is equal to P into delta L. This is the work done. If you want to draw this is in a graph, we can draw a graph like this. Here you take load. Here you take load. Here you take distance. Now if you draw a graph, you can draw the graph like this. What is this? This is load. Load is acting over a distance of delta L. So if you want to find the work done, area under the curve, area under the P into delta L, that will give the work done. Similarly, this equation is suitable for moving a load from one place to another place. But our case is different. But our case is there is a body. There is a body. Here it is fixed. This end is fixed. Here body is not going subjected to motion because in the strength of materials, body is in another stationary condition. Now the load P is applied. Now the load P is applied. So here deformation takes place. The material is deforming and it is compressed. And it is compressed. How much it is compressed? It is compressed by the value delta L. Here what is work done? Here's what is work done. Here you cannot take as like the previous case. Here take let me explain this by comparing a spring. You take a spring like this, load is applied in this direction, load is applied in this direction, load is applied in this direction. Now the load P is acting, load P is acting. So now what is the amount of force required to compress the spring? We are going to see for different condition. Let us take, if you want to compress the spring by this much amount, and if you want to compress the spring by this much amount, if you want to compress the spring by this much amount, the load will not be same. The load will not be same. If you want to compress the spring by lesser amount, we need less force. If you want to compress by more, you need to apply more force. So it is a function of distance. It is a function of distance. As if you want to increase, you want to compress more amount, you need more force. But here it is not like that. Here in this case, it is not like that. For to move the body from this position to this position, the amount of force applied is constant. Amount of force applied is constant. But in material like spring or material like this, when load is applied, the amount of force required is not going to be constant. It is going to be varying. It is going to be varying linearly. So here we have drawn graph like this. If you draw a graph for this case, the graph will be like this. It will be like this. It will be like this. Here you take P, here you take delta L. This is a distance. This is P. This is P. Initially it is 0. Gradually it is increasing. Linearly it is increasing. It is maximum. Now, work done for this case will be area of this curve. Area under the curve. That is half into P into delta L. Right? Half into P into delta L. This is a case. So you have to see the work done means always we take force into distance, but in case of strength of material, and the material is stationary, when load is applied, it is compressed by delta L. The work done is equal to another half into P into delta L. So now I am going to find work done. Work done. Work done is equal to what? Half into P into delta L. Already we know what is delta L. Delta L derivation already we have seen. What is delta L? Half into P into PL by AE. PL by AE is a delta L. Already we have seen this in the previous slide. PL by AE. Now, what is P by A? So now you multiply this equation and divide this equation by A. What is A? Area. You multiply I and divide this equation by A. Now, what is P by A? Load by area is equal to stress. Load by area is equal to stress. Similarly, here one P is there, here one A is there. So there are P by A is equal to, so now if you rewrite this equation, 1 by 2 into sigma square, right? P by A is 1 sigma, another P by A is another sigma. Sigma square PL by A, right? Sigma 2 sigma square into, here we have L, here we have area. Area into L divided by E. A, what is area by L? Now you take a body like this. The cross section area is A and length is L. What is A by L? A by L is equal to volume, right? Cross section area multiplied by L, that is equal to volume. So you can write it as a volume. Now the work done equation is half into sigma square divided by E, sigma square by 2E multiplied by volume. So this is the equation for work done. The amount of work done on the body is stored in the form of what? Strain energy. Work done or strain energy, both are same. Both are same. Now you come to the slide. See, here we have seen different work done in normal case and in strength of materials. Here, see proof resilience. This is a equation. This equation we derived sigma square by 2e into volume. But that is proof resilience. Modulus of resilience or resilience. That is what is that? That is energy stored per unit volume. This is total energy. This is energy stored per unit volume. So if you divide this equation by volume will cancelled. You will get this equation sigma square by 2e. Right? Resilience is energy stored per unit volume. But what is proof resilience? That is maximum energy stored. So here volume will be there, here volume will not be there.